In this video, we're going to look at converting polar equations into rectangular form. So we're going to go from some kind of expression in terms of r and theta, and we want to create an expression that would make the same graph on the rectangular coordinate system that's only in terms of x and y. And we have our three conversion formulas that you're going to be using. X is equal to r cosine theta, y is equal to r times sine of theta, and x squared plus y squared is equal to r squared. And so let's look here at this first problem where we have tangent of theta is equal to 2. Now, my conversion formulas are in terms of sine and cosine. So I would rewrite tangent of theta as sine of theta divided by cosine of theta, and that is equal to 2. Well, I can't just jump in and say sine is y, cosine is x, because our conversion formulas say that both sine and cosine have to be multiplied by r. So I'd have to multiply both the top and the bottom of that by r, and that's going to give me r times sine of theta divided by r times cosine of theta is equal to 2. Now we can exchange our conversion formulas here and say, all right, well, that's going to give me y divided by x is equal to 2. Because we have our r sine is y, r times cosine is x, and the last thing we could do is probably multiply the x to the other side, and we have the linear expression y is equal to 2 times x. All right, now let's look at a different one here. All right, so with the polar expression, r equals 5 divided by 2 times cosine of theta plus 3 times sine of theta. And in order for me to convert, I need to see the r being multiplied to the cosine and the sine. What I would do here to start this problem is I would multiply by this denominator. So I'd multiply both sides by 2 times cosine theta plus 3 times sine of theta. I'm going to multiply on the right, and I'm going to multiply here on the left-hand side. And that's going to take it off on the right, so those two would cancel. And my new problem here would become r times 2 cosine of theta plus 3 times sine of theta is equal to 5. And here I would distribute the r, and that's going to give me 2 times r cosine theta plus 3 times r sine of theta is equal to 5. Now we're ready to do our conversions because r times cosine of theta is x and r times sine of theta is y. And so our answer would be, in terms of a rectangular form, would be 2x plus 3y is equal to 5. And I don't necessarily have to rewrite all of these to be y equals. This is adequate because that's the standard form of a line. Now let's look at another one here. And each of these problems kind of has its own unique approach in terms of being able to convert it. If I'm looking at this one, r is equal to 2 sine of theta minus 6 cosine of theta. I need to have the sine and the cosine functions both being multiplied by r so I can convert. So what I'm going to do here is my first move, is I'm going to multiply both sides by r. And in doing that, that's going to give me r squared is equal to 2 times r sine of theta minus 6 times r cosine of theta. Well, now we can do our conversions because I know what r squared is. R squared is x squared plus y squared. R sine of theta is y, and r cosine of theta is x. So we're going to exchange our polar equations for rectangular ones at this point. So r squared is x squared plus y squared. And I have 2 times y minus 6 times x. So that's a rectangular form. Now, what I'm going to do is I'm going to continue on through this process. And so what I'm going to do is I'm going to move everything to the right-hand side, and I'm going to complete the square. So I have x squared plus 6x, and I have over here, I still have plus y squared minus 2y, and we have equals 0 right now. Now the process of completing the square, in case you forgot, is I'm going to work through here, and I have x squared, so that's going to make x. I'm trying to figure out, all right, well, what do I square to create this middle term of 6 times x? Well, you're going to divide that number by 2, and that's going to come down here. So 6 divided by 2 makes 3. And then you're going to square it, and you're going to bring it back up here. So 3 squared is equal to 9. Now, if I put that positive 9 on the left-hand side, I have to put that positive 9 on the right-hand side to maintain my balance. And then we're going to continue on, and we got to do the same thing for y's. All right, so I have y here. I'm going to half that 2, so divide it by 2, and I put it down here, so that makes minus 1. And then I'm going to square it. 1 squared makes positive 1. And then I have to put a positive 1 over here on the right-hand side. And so that gives me a right-hand side of 10. So the equation that we have is x plus 3 squared plus y minus 1 squared is equal to 10, which is the standard form of a circle. So here I have r equals 2 times secant of theta times tangent of theta. Well, our conversion formulas are in terms of sine and cosine, so I would rewrite this problem, and so that way I see it in terms of sine and cosine. So I have r equals, I'd have 2 over cosine of theta, and then times tangent, so times sine of theta over cosine of theta. And now I'm going to work to proceed. Well, I have 1r over here on the left-hand side, and so if I choose to multiply one of the cosines over, so I'm going to multiply this right-hand side by cosine of theta, and I'll multiply the left-hand side by cosine of theta, and that's going to make those two cancel. And so what we have right here at this moment is we have r times cosine of theta is equal to 2 times sine of theta over cosine theta. Well, we have the r times cosine on the left. I just need these two trig functions on the right-hand side to both be multiplied by r's. So my approach is I'm going to multiply the top and the bottom both by r of that fraction there, and that's going to give me r cosine of theta is equal to 2 times r sine of theta divided by r cosine theta. And at this stage, we can convert everything now. And so I would have x equals 2 times y over x. And I could just simplify this a little bit and say this would look a whole lot neater if I would just multiply both sides by x at this stage. And then make those two cancel out and have a rectangular form of x squared is equal to 2 times y, which we'd have a parabola. Y equals 1/2 x squared. All right, let's look at this next one that we want to convert into Cartesian or rectangular form. And so I'm looking here at this next problem, and I'm going to look and say, all right, let's multiply the 1 plus sine of theta to the other side. So I'm going to multiply both sides by 1 plus sine of theta. And when I do that, I'm going to have r plus r times sine of theta is equal to 4. And I'm going to go ahead and say, hey, let's go ahead and convert r sine of theta into y. And so we have r plus y is equal to 4. And then I'm going to move the y to the other side because the problem that we have really is this r that's not being multiplied by a trig function. So I'm going to wind up having to square it. But before I square it, I want to isolate it. So r is equal to 4 minus y. And now we're going to square both sides. So I'm going to square the left, and I'm going to square the right-hand side. And we have r squared is equal to 16 minus 8y plus y squared. Now we can exchange the r squared. R squared is equal to x squared plus y squared. And we're looking here, and the y squareds are canceled at this point. And we'll have a rectangular form of that equation to be x squared equals 16 minus 8y. And we can leave it like that. Okay, let's look at converting this next problem here into rectangular form. And what I'm going to do here is I'm going to look and I'm going to multiply the denominator to the other side. So we'll multiply by 16 cosine squared theta plus 9 sine squared theta on both sides. So I'm going to bring that up out of the denominator. And what that's going to give me is my right-hand side of this is going to become 72 times sine of theta. My left-hand side here is going to have, I'm going to have r times 16 cosine squared of theta plus 9 times sine squared of theta. And we're trying to get rid of all the r's and everything in terms of theta here. And an issue that we have is we have sine of theta over here on the right side, but it's not r times sine of theta. We also have an issue on the left-hand side where if I were to distribute the r, I would have 1r times cosine squared, which r times cosine makes x, but to get rid of the other cosine that's multiplying to it, I'd have to multiply by another r. So from here, we're going to multiply both sides by r, which is going to give us r squared times 16 cosine squared theta plus 9 times sine squared of theta is equal to 72 times r sine of theta. Now if we were to distribute the r squared on the left, we'd have 16 r squared cosine squared theta plus 9 r squared sine squared theta is equal to 72 times r sine theta. Well, this piece, r squared cosine squared, that is the same thing as if I had 16 times r cosine of theta quantity squared plus, and r squared sine squared would look very similar. That's the same thing as r times sine of theta quantity squared, and I have equals 72 times r sine theta. Well, we'll go in and now we'll replace all of the r times sine of thetas and r times cosine of thetas with their polar form. So I'd have 16x squared plus 9 times y squared is equal to 72 times y. And there's a rectangular form. Now I could continue on here and say, all right, well, if I could identify that this was an ellipse, I would go through the process of completing the square so it would be in its standard form. And I'd complete the square for the y term. So I'd get the 72y on the same side. So minus 72y is equal to 0. And I would have to factor out a 9 so that way I could do the completing the square process. And so I'd have 16x squared plus 9 times, and I'd make y squared minus 8y and equals a 0. And so we're going to look at completing the square on the y term over here. And so we'd have 16x squared plus 9 times, and our goal is to try to get some binomial being squared, and I'd have y in here. And so you have the number in front of the y to the 1 power, so that makes minus 4. I'd square that number, put it back up here, so I square -4 makes positive 16. And then my adjustment on the right-hand side is not going to be 16 because it's going to be 16 times 9. And so 16 times 9 on the right-hand side is 144. So I put 144 on the right-hand side. And the last thing, to have this in standard form for an ellipse, is I'd make that right side equal to 1. So I'd divide by 144 everywhere. And in doing that, what we would have is x squared divided by 9 plus y minus 4 squared divided by 16 is equal to 1. So there is a rectangular form for that polar equation. Okay, let's go on down here to this next one here. So this one, all right, we want to get this written in terms of x's and y's. And we have r squared equals cosecant of 2 times theta. Well, none of my conversion formulas are in terms of multiple angles. They're all r cosine theta or sine of theta. So I have to do some work here where we don't have a double angle formula for cosecant. So I would need to rewrite the cosecant of 2 theta. And so my right side becomes 5 divided by sine of 2 theta. And our double angle formula for sine of 2 theta would be what I would use next. So my next line would be r squared equals 5 divided by sine of a double angle is 2 times sine of that angle times cosine of that angle. Now from here, I would multiply to get that my trig functions out of my denominator. So I'm going to multiply by, you can multiply by the whole thing if we want. So let's do 2 sine theta cosine theta. And so what we have is we have 2r squared sine of theta times cosine of theta is equal to 5. Well, we can use our algebra technique here and say, well, r squared is really r times r, and multiplication is commutative. So I could rearrange this as 2r sine theta times r cosine theta is equal to 5. And then use my conversion forms for r sine of theta times r cosine theta, and we get 2 times y times x is equal to 5. And we'll leave this one just like that.